So welcome to another video. My name is Dr. Adam Alsmedisi. I am a geographer, and I've been making a couple of posts suggesting some technology that I think can help bring GIS, geography, data science in general to the classroom. Now, in my previous video, I made an app where there was a slider, and on the left side there was a historic map from the mid-1800s, and on the right side was today's satellite image. And you would be able to see the differences between what was drawn out back then, where you had bakeries and old companies, etc., old roads, and the geography of today. So instead of an old bakery, you might have a Best Buy or something. Anyway, that utilized this slider feature within the Google Earth Engine apps. And I wanted to bring out the slider again, but this time I wanted to use satellite imagery. So these are two satellite images, and if you know this area, if you're from the United States for sure, you know that during this past late summer, there were a lot of fires in California. It, of course, exacerbated the pandemic situation. There were a lot of air quality issues in California, etc. Now, this is how scientists track this, and I think in high schools, they don't really, in environmental science classes, dig into this. They don't really show the wealth of Earth science data available. Now, you can see this very cool image. Basically, this image, and I'll mention you're not actually looking at the real color. Obviously, it's pink, but this is a special way to visualize healthy vegetation and dead vegetation that maybe I'll get into later. But this image was taken, both these images were taken by Landsat 8, which is a observation satellite. Here's the Wikipedia page. So done by the U.S. Geological Survey, USGS, and NASA. Here is the actual satellite. And what it is doing, what all satellites are doing, you can see from this video, are going around the Earth in the same position, many of them, but the Earth moves, of course. And so Landsat, for instance, the satellite that gave us these images, goes around the Earth and it takes a picture of the same place every 2 weeks, which is a really good temporal resolution. So it's allowing us to see before and after fires in Northern California. And I should say Google Earth is built with Landsat data, Yahoo Maps, a lot of Maps apps are built with this satellite imagery data. Satellite imagery is a long field, or an old field. In the grand scheme of things, it's not an old field, but they've done a lot in maybe a shorter period of time. I guess it really emerged in the 1970s, and certainly observing the Earth for environmental science is great, but of course a lot of it developed because of wartime. But for so many reasons, seeing changes over the Earth is really important and interesting. And so you might even think of other places where, and this might be the assignment that I suggest, is after you watch this video and you see how to make the slider, and I will provide the code, so it's actually super easy. You can modify it to look at images from a different place and two different time periods. So if you wanted to assess hurricane damages, for instance, that might be a use of Landsat. Whatever. Now, there are many other satellites. They have different attributes than Landsat. That's kind of getting into the weeds. I'd say Landsat's probably the most popular, but the other ones certainly have their roles and purposes. But right now I want to show kind of, I think, manageable project for your average secondary school student in an environmental science class to make one of these slider maps. So we're going to start with using Google Earth Engine. And briefly, Google Earth Engine is an amazing platform to do this analysis. It's a new platform. Now, previously, if you wanted to do a project like this, or if you wanted to analyze this data, you would have to download these files one by one from NASA or a government website. Now, you'd have to download literally like hundreds of pictures. Why? Well, because you have to throw out a bunch of them, and some you can save some pixels, but you can't save other pixels because of clouds. Excuse me, because of clouds. So you have clouds blocking certain aspects of the picture, and you can kind of patchwork together, and that's what Google Earth does. Patchwork together the best pixels, and that takes a lot of work. So it's hard for you to do a lot of science after you do that management. Now in comes Google, and this was in combination with NASA scientist. Google hosts, manages all these files, and provides a platform for you to use a JavaScript-based language. I'll show you right here just briefly. JavaScript-based language, in which you can organize this data set, these many data sets. We're not talking about just Landsat 8 here. We're talking about previous Landsat satellites. We're talking about all satellites. We're talking about census data, all geographic data for you to analyze in a browser. So all the data is kept in Google servers. All the analysis is done at Google servers. And so it's just an amazing way for you to do high-powered computing and Earth data science on your own computer or on even Chromebooks. Okay, so I'm going to show again how to make this kind of swiper map, and I will in just check that real quick. Okay, I will in the blog post the code. Now, when you're signing up for Google Earth Engine, you have to like certify your Google account some way. I'm not really sure how it works. I did it a long time ago. I know it's free, so if anyone has any trouble with that, they can certainly send me an email. So let's get to the code editor. You can see how it's laid out here. Scripts. There's three things here. The inspector, which I'm actually going to use because I need to make a point. And I'm just going to click. I need to get that. Well, that would actually be okay, I think. This would be good. Okay, so I'm going to put a point here, and I'm going to call it point. Okay, and basically I'm only going to look at, remember I showed you the satellite goes around the world, so that means there's a picture of every location in the world. By putting the point here and writing the code as I'm going to write it, it's only going to pick out images from that point. Let's first we'll put in the first line of code. Variable L8 is equal to, oh my gosh, Earth Engine.image collection, And then here, now you can like search over here for this data set, but I have it right here in my notes. So if I looked up Landsat 8, here's the Landsat data, and you can click on those and find them. Anyway, now this says we're going to look at Landsat. It doesn't say we're only going to look at Landsat at this point. It doesn't list any specific dates, and that's what we need to do first. So the first thing we're going to do is make a new variable called variable spatial filtered, and that's going to be equal to L8 dot filter bounds point. So what that means is that I'm going to make a new variable called spatial filtered. That's going to be all the images in Landsat that are within the bounds of this point. And now I'm going to do another one called var temporal filtered. And I'm actually going to make this one. That means because we're going to look at the same location for two different time periods, this will be for the first time period. It's going to be equal to spatial filtered dot filter date, and here I'm going to put in, copy and paste this so I don't make any mistakes, May 1st to June 30th. Okay, I just want to make sure that I'm getting some time in the early summer. And then I want to look at a second time period. Again, I'm calling spatial filtered, but this time my filter date is going to be, and I played around with this to look at the images. This one's going to be in mid-October to mid-November. Now, the fire was earlier in September. We're looking at the August complex fire, which is the largest fire in U.S. recorded history. And the pictures were useless because instead of clouds, they were just smoke. So you couldn't really see anything. So this is a few months after now. That'll have an effect, but we'll talk about it. Anyway, I'm going to make a new variable called sorted1. That's going to be equal to temporal filtered 1. So remember now these are just the images that were in this location on these dates, but I want to filter it so that I sort them by cloud. Cover. So here, and I want to duplicate that and put this for number 2. So here, if there are multiple images, which I think in both cases there would be at least 2 images, we're going to pick out the one with the least cloud cover. Now comes the bit of a tricky part, at least to explain. So I talked about Landsat, I talked about the images you get. Now the images are comprised of multiple bands because they have multiple sensors that pick up red, green, and blue like a normal camera does, but can also pick up different bands. It can pick up near infrared rays and shortwave infrared. Okay, it can also pick out clouds, cirrus clouds. And to be honest, because remote sensing isn't actually my technical background, I can't answer all that much about it. I kind of go with what they'll tell me and work with it. But what you can do is combine these bands, right? And so here's this blog. They're showing how these bands can be combined differently. Here's just like natural color, right? So true color is what you actually see. But here, for instance, you're using, I think there was like 11 total bands. Here they all are. So for instance, if you use bands 7, 6, and 4, you're going to be able to really identify urban areas. And over here, you can pick out land from water because, right, you're looking at shades of orange and green. There is also, here's the one we're going to use, 752. Or I'm sorry, that's the one I used in the app. I'm going to use True Color on this one. Guess they don't have the one. Well, I don't want to go too far down the road. We're going to work back over here. So here we're going to use bands 4, 3, and 2, which for the record is for red, green, and blue. So RGB. And I set the max to 19. That's a parameter you're going to want to change based on the images you wind up choosing. So first, I'm going to go over here. And pick only the first image of these cloud cover, sorted by cloud cover images. And if I just want to quickly do a map.add layer, I can add scene 1. And remember, I made this variable visualization parameters. I just add that too. And if I run this, I should see, yeah, there's the first image popping up. Amazing, so fast. And if I want, I can also do, but this isn't I want because it's sloppy. If I run this, then I can choose between layer 1, layer 2, and I can also, for what it's worth, name them before fire and after fire. And if I run that and see how fast it runs, it's amazing. And there you can see the severe differences. Anyway, I'm going to delete these 2 lines of code because I want to present this as a slider. So this actually requires part of the code that I already showcased with the historic map. So if you want to go back and copy parts of that or learn from that, you certainly can. But like I said, this code will be uploaded to the blog. First, I'm going to make, and I'm just going to copy it because there's no point in me doing extra work. But in this line of code, I make 2 new variables, and they are using widgets for the user interface called maps. So I'm making new maps based on the user interface. And here I am making scene 1 and scene 2, which are the first most cloudless pictures, right? And this is an artifact, but I'm going to get rid of it over there. And I'm also making them layers that can be used in that kind of widget. Now in these lines of codes, I'm saying there's this layer list called left scene layers and right scene layers, and I just want to add left scene, which is this map layer, to the left one, and right scene, which is this right layer, this map layer to the right one. Finally, I add this code. Not finally, I don't know what I'm saying. I'm also making a new variable called split panel, and this is based on a widget that is a split panel. It says that I now I can have multiple panels, but I'm only going to use 2, the left map and the right map, that are going to be oriented horizontally next to each other. Now, when I wipe true, it means that when I move on one side, it'll move on the other. So these 2 lines of code, the first means that root clear means don't show any default map. Clear all that and just add that split panel, that thing that I coded right over here. And then finally, 2 lines of code. One link means I'm going to link these 2 maps together so that when I move on the left, it moves on the right. And here I'm going to set the center right around this point. And I'm going to do it only in the left map, but remember, because they're linked, that when I'm near the left map, it'll be with the right map. Bada bing. So if I run this, here you go. Beautiful. Here you see this is again true color, so you don't have to get into the kind of bands discussion, but you can really focus on fire here and how expansive this fire is. Now, if you wanted to do more analysis, you could actually quantify how many cells, for instance, changed value or what have you. I can quickly show you that if I put on that band combination that I showed you earlier and add just a couple of letters, here we go. Again, the pink will show the fire scars, and so you can kind of quantify that and find out some information there that might be interesting. But just the process, I think, is a really interesting first sifting through this type of data and thinking about representing different phenomena with these data. So there's the code. Like I said, it's going to be uploaded online. I will also put sliders for both the true color and this vegetation highlighted band combination for you guys to view. And if you have any questions, let me know. But I think, again, you can share this page with your students. They might be interested in showing an area they know has changed a lot. And there will be a few other projects I'll post that also I think do a nice job with that. But I think that making something interactive like this is pretty neat. So I hope you enjoyed. I hope this is helpful. Thanks very much.